Hello, everyone. Thank you all for coming to some lightning demos. We're going to kick things off today with Emre. He was also around during keynotes yesterday and did a live demo there. But we're here to learn more about Canonical and Ubuntu and automated disaster recovery. So, everyone, here is Emre.
Thank you. Thanks for coming and joining this lightning demo. Before starting the demo, as you may have heard from yesterday, the topic is migration from VMware to OpenStack. At Canonical, I mentioned yesterday, probably this migration part is the last mile of getting a success in your migration. But before than that, you have to build your new infrastructure. And that's where you will be spending some time. And OpenStack is a learning curve also for some people, for many companies. And we are here to help, obviously, in this learning curve. But this learning curve should not be preventing you of, just forgetting the basics of a highly available, resilient, secure environment. So in this manner, let's start in your, in your head how things get started. Like when you want to host applications with OpenStack, you are, an administrator. The first thing that you will do is probably creating some availability zones, and you want a highly available system. So you create your AZs. Next step for you is probably creating an image catalog. So this is from where you will get your images and you will deploy them in a highly available fashion. Next step is to provision. So you will be provisioning this in this highly available manner with all the replicated units. You will be obviously taking care of the storage, and then you will be taking care of the accessing this environment with probably a load balancer and all the firewall rules that you need to put in place. So this is in VMware, probably for some people, they are very used to do that. It's already built in if I say NSX, probably many people are thinking about maybe microsegmentation, about distributed firewall, about features that could be even advanced or very basic. So here in OpenStack, we have already features that are providing such networking features in the security group with Neutron. So now you want to obviously have high availability of your hosted applications also, not just the networking part. So in the networking space, you can use bonding and some other techniques in the hardware side also to create some kind of high availability. On the workload side, probably people have heard vMotion and the way to evacuate some VMs from some compute node that are failing to others. It's a built-in feature also on VMware. But in OpenStack, there's also a service, and there are multiple services that probably people are not yet aware of, and they were existing for some quite of time. And there are some POCs that were showing this. And actually, the demo that I would like to show you today, it's not new. It's not rocket science also. It's about Masakari. If you have heard about Masakari, it's the high availability system for workloads in OpenStack. Really, the situation, think about a situation where you have for instance, your networking. It could be tenant, management, storage networking, where you have an outage on a compute node. What should you do with the existing workloads running on this compute node because they are lost? You have to evacuate them by somehow, and if it's automated, that's perfect. That will be one condition, an unexpected outage. Or if you want to do a planned maintenance, you want to evacuate your workloads to another compute node, do your maintenance, and then come back to the initial state. So really here, the solution I would like to show you is Masakari, how it provides this high availability. And actually, there's a link. You can, if you are not familiar with Masakari, you can go and look at it. There's a demo architecture that we put in place with Sunbeam, our cloud-native model of installation of OpenStack. So the idea is we will be running 3 compute nodes in this demo. And there will be one compute node where there are 2 VMs running. The idea is to simulate this network outage. Here we are using also another service called Consul. So Masakari is here to do the evacuation and to do the underlying job, but we need to also look at with the networking side to do some pings using a TCP protocol, and that's the job of Consul. Basically, Consul, the way it works, there's a client running per network. We have 3 networks in this example, as I mentioned: management, tenant, and storage. Once the client sees that there is something going wrong, there's unreachability on the network, it will be talking to what we call a Masakari administrator. And from there will be some messages going to Masakari engine and to Nova API to make sure that we are shutting down the Nova compute on the faulty compute, and we are evacuating the workloads on a live compute that is available in the system. So let's switch to the demo, and I have a video of it, so I will be showing you some details. So I know that it will be very small, but I will make sure to explain. So the idea here is I have 2 VMs. The 2 lines, VM1 and VM2, they will be running on one compute right now. Bless you. So if we look at the compute 1, and if we check if there's any virtual machine running, there's none at this stage. Again, coming back to compute 1, we can show what is running underneath all these computes. So we have some snaps that are running, what we call the OpenStack hypervisor snap. So here, let me just pause a little bit. What you don't see here, probably it's very small. There's a Consul client running as snap services. There's also what we call a shutdown listener, VM shutdown on the OpenStack hypervisor snap running a service that will be constantly looking for this kind of network outage. So if we move forward on this demo, today we have these 2 virtual machines running, the 2 instances on compute 2. If we fast forward a little bit, probably you will see that we have a, let me just fast forward this for you. Yeah, so I would like to show you this, the logs on the Consul side. The idea is that there is always a periodical checks at the TCP side to make sure that the compute node is answering. These are the TCP checks that you see. This is here, the interval is every 10 seconds. We are looking, and we can configure that, obviously. As long as the TCP checks are done, okay, so we're good. Now let's simulate our network, like this ENS3 interface that you see on the top. We put it down, and here let's see what Consul will be mentioning. The idea is to really simulate a network outage here very quickly. If we look at these logs on the bottom, you see that there's a TCP check failed. So this is where Consul is aware of the problem. Network is unreachable. The next step is obviously to mention that to the other services. Now, if we look at compute 2, the result of this outage, I had 2 VMs running on this compute 2. They disappeared. I don't see them. And that's part of the beginning. So these VMs have been evacuated. They are still running, actually. What you will see, let's go, yeah. what is interesting here, if we look at the Nova Compute service, it was up on the Compute 2, and now it's down. The Nova Compute service has been put down on the Compute 2 where we lost the network. We have, obviously, we can look at the logs also and see what happened. If we look at the logs, and this is, bear with me, you will always, like engineers, would like to look in the logs and see what happened. If you see the Masakari monitor here, it went to see that there's an outage on the network, and it started let's say, to tell Nova to do this evacuation. So we'll be also looking at the next step. Let me fast forward this part also, just not showing just the logs. If we look at the Nova API logs, we'll be seeing that we have started this evacuate of the VMs. So that's the job of Masakari, talking to Nova. And now, where are the VMs running then? So this is configurable. It's up to you to be, especially when you have workloads that are dependent on the compute node. You need to make sure to select the right compute nodes where you can migrate your virtual machines, especially if you have GPUs and so on. So the VMs that are still running here, if we check where they are, now they are on compute 1. So that was the simple explanation at a high level more of Masakari. The goal here is to make sure in case of a outage, we have an aggregated list of hosts where we can migrate our VMs. Again, I was talking to probably some telco folks also. There are some hardware dependencies that you may have, or CPU dependencies, so you need to just be careful about the configuration. It's all about configuration after that. But I wanted to show you, it's here, the VM migration. It's one of the services of OpenStack that is available that today we can use in either hyper-converged architecture or disaggregated architecture. And the good part here is we don't have to kill the entire compute node and so on. There are some services that we can restart and we can do this migration. I hope that this gives you a little bit insight on Masakari. I just asked during this yesterday and today a few folks if they heard about Masakari, and I don't see everyone being aware, but I see on VMware, everyone knows vMotion. So that's why it's part of a DR strategy on the same cluster, on the same site. It starts from Masakari, and we have to obviously think about how to expand this to multi-cluster architecture, and I hope that it will give you some ideas in your projects. Oops. Next one. So for the questions, what will be good, probably for time reasons, we have 2 minutes, I believe, left. You can come to our booth. We have our engineers also. We have our technical folks. And I know that there was also a more technical conversation with my colleague Guillaume Boutry on this Masakari and Consul. He may have done a little bit a different demo on this. We'll love to show you how it's being done under the hood if you are interested to understand the different logic. Or if you want to understand how you can apply it in your OpenStack environment and how it can help you to migrate from VMware to OpenStack. Thank you.